Hello and welcome to The Explainer. Today, we are on the trail of a 50-year detective story. We're going to trace the clues that took science from a single, mysterious smudge on a photograph all the way to a weapon that could change the world forever.
This question from physicist Frank Close really gets to the heart of it, doesn't it? How do you go from one tiny, accidental clue to a power that can literally end civilization? That's our starting point. We're going to follow this case just like the scientists did, one breadcrumb at a time.
Okay, so let's dive right in. Our story doesn't begin in some top-secret government lab. No, it starts with a complete accident in Paris, a total fluke.
So picture this. It's 1896. Henri Becquerel is doing some experiments, but the famously cloudy Parisian weather isn't cooperating, so he just shoves everything in a drawer. Later, he develops a photographic plate that was sitting next to a lump of uranium. And what's this? A faint smudge. It was the very first hint of some vast, hidden energy source leaking out from the very heart of matter itself. The big question was, what was it?
Well, the first detectives were on the case immediately. You had Marie and Pierre Curie jumping in, finding new elements that were even more radioactive. Then, a guy named Ernest Rutherford figures out that this crazy energy is actually coming from deep inside the atom. But that's just created a new puzzle. All this incredible power was locked away, just kind of dribbling out over thousands of years. I mean, it was fascinating, sure, but it wasn't useful.
So, to unlock that energy, the scientists first had to understand the crime scene, And the crime scene was the atom itself. They had to get a complete picture of what it was made of, but they were missing a crucial piece of the puzzle.
The picture started coming together, piece by piece, kind of like assembling a suspect profile. First, J.J. Thomson finds the electron. Then Rutherford discovers this tiny, dense nucleus at the center. But the math was still off. The atom's full weight didn't add up. It wasn't until 1932 that James Chadwick found the final crucial clue, the neutron, the missing piece.
And just like that, they had the whole lineup: protons, neutrons, electrons. They figured out that the protons and neutrons were bound together by this incredibly powerful force, holding back an unbelievable amount of energy. So the question wasn't, is the energy there anymore? The question became, can you get it all out at once?
All right, this is where the investigation takes a huge, dramatic turn. We're in the late 1930s. A team in Berlin stumbles onto something they just cannot explain. But it's going to take two physicists, exiles, on a walk in the snow to finally crack the case.
So who actually gets the credit for this world-changing discovery? Well, that's where things get a little complicated. See, it's one thing to see the evidence. It's another thing entirely to understand what you're looking at. The official credit often goes to the chemists who saw the results first, but that's not the whole story.
Okay, so check this out. In Berlin, you have these brilliant chemists, Otto Hahn and Fritz Strassmann. They're doing their experiments and they find barium. Now, barium is about half the size of uranium, and they are completely baffled. They have no idea how it got there. Meanwhile, Lise Meitner, Hahn's longtime partner, who had just been forced to flee Nazi Germany, gets a letter from him describing this bizarre result. And on a walk in the snow with her nephew, Otto Fritsch, it hits her, the aha moment. The uranium atom wasn't just chipping off a piece. No, it was splitting in half. And in the process, it was releasing a ton of energy. They called it fission.
And this is the moment. This is where our little scientific detective story completely transforms into a high-stakes suspense thriller. Because this breakthrough doesn't happen in a vacuum. It happens on the brink of World War II, and the implications are immediate, staggering, and frankly, terrifying.
Pretty quickly, scientists figured out there was a catch. Only a very specific, very rare type of uranium, U-235, could actually start a chain reaction. And when I say rare, I mean it. For every 1,000 atoms of uranium, only 7 of them are U-235. Because of that, most physicists thought a bomb was basically impossible. You'd need tons and tons of the stuff.
But in 1940, two physicists in Britain, Rudolf Peierls and Otto Frisch, yep, the same Otto Frisch from that walk in the snow, decided to check the math. And their calculation revealed a truth so shocking it would literally change the course of history. The amount of U-235 you needed wasn't tons. It was about 1 kilogram. I mean, just read that quote from their report. They knew exactly what they had discovered. It was laid out in the starkest possible terms. In an instant, the impossible became horribly, terrifyingly possible. And with Nazi Germany working on its own program, the race to build the bomb before Hitler could had officially begun. So this massive effort, the Manhattan Project, gets underway. But as it grows, the goal starts to change. It becomes less about stopping Hitler and more about just building the weapon. And not everyone was okay with that. There's a story here that often gets forgotten, the story of the project's moral conscience.
I want you to meet Joseph Rotblat. He was a Polish physicist, and he joined the project for one reason and one reason only: to defeat the Nazis. He'd lost his wife in the Holocaust, but for him, the mission was crystal clear. So in late 1944, when it became obvious that Germany was going to lose the war and that they didn't have a bomb, he walked away on moral grounds. He was the only scientist on the entire project to do so. He spent the rest of his life fighting against nuclear weapons, and he even won the Nobel Peace Prize for it.
This one detail from Frank Close's account, just let it sink in. He lived to 94, he never remarried. It says so much, doesn't it? It speaks volumes about the profound personal cost of that time, about a life shaped by this incredible loss and this incredible moral conviction.
So we followed the trail from a faint smudge in a drawer to a weapon that could alter the world forever. It's an incredible story of how pure, simple curiosity can lead to consequences that nobody could have possibly imagined. And it leaves us with this question, one that we are still grappling with today. When a discovery has the power to both save us and destroy us, who's responsible for the path we choose? If you enjoyed this explainer, please consider subscribing for more deep dives into these complex topics. Thanks for watching.